Okay, so I'm going to go over some subnetting basics. The first thing I would like to mention is the prerequisite knowledge I'd like you to have is I would like it if you could identify a network's IP class and how it's subnetted. So I'll put a link in the description which goes over that. Very short. I think it's going to be like 4-minute video. Easy. Not hard to do at all. So now some subnetting basics. So I'm going to give you an example of a subnet mask. So this is going to be a /24. It's a very common, very common subnet mask, typically found in an address such as 192.168.23.54, whatever, right? So what a /24 subnet mask looks like, if you were to write it out as almost like a network address, it's going to look like 255.255.255.0. So when you see /24, what that means is that the subnet mask is 255.255.255.0. So what does this mean? This 255.255.0. Well, the IP addresses which use 4 octets. So let me get out my marker here. So we have 1 octet, another octet here, a 3rd octet, and a 4th octet. So IPv4 addresses, they use 4 octets, right? So these octets, each of these individual octets are made up of bits. So each octet, so this first octet, it has 8 bits. The second has 8 bits. The third octet has 8 bits. And even the 4th octet, which is 0, has 8 bits in it, right? So there's 32 bits in total for an IP address, or for a subnet mask. There's 32 bits in total, right? So the first thing to realize is that the bits are in binary, right? And this is how they work. So you have the numbers 128, because there's 8 of them, 64, 32, 16. Notice it's just halving itself. 8, 4, 2, and 1. So if you take, let's say if you took 255, right? So 255 is composed of 8 bits, because each of these individual octets is composed of 8 bits, right? So this number 255 is made up of 8 bits that are determined in binary, right? So if we have 128 here, we have a 1 underneath it, because in binary you have 1s and 0s. 1 is kind of like yes or add, and 0 is like no or don't add or don't have, right? So 255, so you'll have, so this is like 1 bit, right? This is the 2nd bit. This is the 3rd bit, the 4th, the 5th, the 6th, the 7th, and the 8th. So there's one. So if you take these, right? So these can also look like this. These bits, it can also turn out like this. Here, you know what? I'm just gonna. I could probably just copy these. I can just do this. Copy, paste these. I'll just put these down here, right? So those bits, just to save time, so I don't have to write all these out again. Okay. So these can also be written out like this in binary. You can have 1, 1, 0, 0, 0, 0. Okay? Now, what does this tell us anyway? So what's the point of all this? Well, if you look at the number 255, this number comes from the fact that all these 8 bits are set to on. So the way that this actually works is what these ones are saying is 128, like add 128, okay, add 64, so 128 plus 64, add 32, and add 16, add 8, add 4, add 2, and add 1. So what these ones are saying, so for example down here, before I go over that, is 128, so it's saying add 128, add 64. And then technically it's saying don't add any of these. So we have 128 plus 64, and that's it. So where these numbers are coming from is that these numbers right here are what are composed, these binary numbers, is where we get our 255 in the first octet, right? So these numbers that you see right here are the bits of our first octet. Because if you add 128, 64, 32, 16, if you add all these numbers, you will end up with 255. So in IP addresses, the numbers in the octets, they go up to the number 255 before they switch over to the next number, right? And it's sort of like a clock in IP addresses too, if you think about it. So if this number reaches, if this 54 right here, the fourth octet in this IP address, if this each reaches 255, if you were to add another 1 to it, it would actually become 0, and then this number right here would become 24. So it's kind of like a clock in that sense, that they all go, they flip over like that. And all these can be up to 255. So, this subnet mask is a /24 because, so think about it, there's 8 bits here, right? So if you have 255, right? I'm going to rewrite this again. Let me see here, black. Let's do text. So if you have 255.255.255.0, let's count how many bits are actually in this, because remember there's 8 bits per octet. So we know that 255 means that they're all set to 1, right? All these binary digits are set to 1. So that means we have 1, 2, 3, 4, 5, 6, 7, 8, period, right? So now we're moving on to the next octet, the second octet. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we're moving on to the third octet. So that's 1, 2, 3, 4, 5, 6, 7, 8. And then the final octet, it's just 0. So that means that there's 0 across the board here, right? So if there's 0 across the board, that's dot 0, 0, 0, 0, 0, 0, 0, and 0. So there's 8 zeros here, right? So you have this right here is our subnet mask, which is this 255, 255, 2550 in binary, all right? And so your subnet mask can be any combination of these ones going from left to right with the zeros. Now I don't think you can have like just one here. Like you can't just do that. The ones always have to go from here to here. So you can't have 0, 0, 0, 0, 0, 1, but you can have 1, 0, 0, 0, 0, and so on, right? They have to go in, what is it, descending order, I think it's called. So now that you know that, the way we get our CIDR notation, or our abbreviated subnet mask, now that you know where these numbers come from, is we count the number of network bits. Because another thing that you want to know is that let me put this in black text, your network bits equals your ones, and your host bits equals your zeros. Whoops. Your zeros, right? So now, if we look, so here's a question, how many network bits are here in total? There's 8, 8, and 8. What's 8 times 3? 8 times 3 is 24. And if you look, what's our CIDR notation? /24. So in the end, CIDR notation really is just counting how many network bits is in your binary subnet mask. And again, your subnet mask, it can be any combination of these ones, obviously in descending order. I mean, you can't have, I don't think, like 0, 1. It can't be like that. It can't be like 0, 0, 1, but it could be 1, 1, 1, 0, 0, 0, 0, you know? So, yeah. So, for example, this subnet mask right here, this octet, if we had 128 and 64, assuming the rest are zeros, because that's how it has to go, we could have 192.0.0.0. So that you add these two numbers together, so that would be the subnet mask for this one. But that's how you would find that. Again, this stuff is a bit confusing to start out with, and I'm trying my best to explain as well as I can and as concisely as I can. And then after this, so usually what you'll do in a subnetting problem is they'll give you like an IP address, and then they'll say, okay, here's this IP address. We need this many networks, and we need to, and then they'll ask you, okay, so what's the first IP address of this subnet, and then what's the broadcast ID of this subnet, and those are all some more terminology, and we'll get to those in a bit. But for now, this is kind of like probably the most important basics that you can know. Again, and just to write these out, so /24, we know that's the typical 192. So for like the 172 or like a class B, it's typically /16. So that looks like 255.255. Here, actually, I'm going to write these out. I'm going to write all these out. So again, class A, which is /24, which is just kind of like shorthand for writing the subnet mask, is 255.255.255.0. Class B, which is /16, is written as 255.255.0.0. And class C, which is typically /8, is written as 255.0.0.0. And if you think about the slash again with our CIDR notation, again, where does that come from? Well, if you actually write out all of your network bits, so all of your ones, right? You have 8 ones. Look back up here, that are composed of this 255. And then the rest of the octets are all zeros. So your network bits, right here, you have 8 network bits, and you have 24 host bits sitting here, right? So those 8 bits determine what your CIDR notation is. Same here, it's 16. So we have 8 bits in this one, 8 bits in this one, 8 bits in this 255, 8 bits in this 255. So that means we have 16 ones, 16 network bits in total. So your CIDR notation is basically just a tally of your network bits, and it also tells you what your subnet is, because you can do your binary, and then you can find out what the numbers are. So I hope that that explanation was clear, and I hope that you understand some of these basics.